Hi everyone. So today we are going to discuss a topic which is called as introduction to percentage. Now this topic is one of the most important and super important ideas when it comes to percentages, and this has wide varieties of application that you will see in the chapters that are coming up, like for example profit loss discount, simple interest, compound interest. The entire data interpretation part can be also done with the help of this entire percentages. So whatever we learn today, all of this is going to be uh, very very critical. Now whenever we talk about percentages, the first thing that we should do is something called as learn about fractions, because whenever the calculation happens, these fractions play a huge role in terms of simplifying them drastically. So first we'll learn that, then we'll learn the concepts, then we'll see the question. So that's going to be the flow. So let's start with the fractions and percentages. So the first group that we have is basically 1 by 2. 1 by 2 is 50%. Probably most of you would be aware about that. Then after that, the other number from this group is 1 by 4, which is 25%. So similarly, you can say that 1 by 2, if we do half of that, we get 1 by 4. And that means percentage also 50%. If we do half of that, we get 25%. If we keep continuing this, we can say 1 by 8 will be then 12.5%, because 1 by 4, if you do half of that, you get 1 by 8. So similarly, percentage also becomes half of that, and 25 divided by 2 becomes 12.5 percentage basically. So that's about the next number. Then one more number is there from this group, that is 1 by 16, and similarly we can say it is half of 1 by 8. So that means percentage will also become half of that of 12.5, and 12.5, if we do half of that, we get the answer to be 6.25 percentage. So this is how the whole first group works out to be, and we can continue doing this further and further also. For example, if someone asks you what is 1 by 32, you can say 1 by 32 is half of 1 by 16. That means 1 by 16, we know it is 6.25. So if you do 6.25 ka half, it becomes 3.125 for example. So we can continue doing this, and we can keep getting those answers again and again and again in the similar manner. So that's about the first group. Similarly, we have multiple such groups, and we need to remember these numbers and their answers. So rather than simply mugging up these answers, what we are trying to look at it in a way that it becomes easier for you to understand and then remember it effectively, rather than simply by hearting them. The next group is 1 by 3, which is 33.33%, one third. Then the next number after that is 1 by 6, which is, we can say, half of 1 by 3, which will be 33.33 ka half. That becomes 16.67%. Then there is 1 by 12, which is 1 by 6 ka half, which is 16.66 ka half, which is 8.33 probably. And then last one is 1 by 30. Now 1 by 30 is we can say is not half of 1 by 12, but we can say simply 1 by 30 is 1/10 of 1 by 3, for example. And hence we already know 1 by 3 is 33.33%. So 1 by 30 becomes 1/10 of that, which gives us 3.33%. So that's the only different number in the entire list. The rest all number have the same logic, that is half of the previous number, and so on and so forth. So numbers, if you can understand in such contexts, it will be easy for you to understand these things also. Then after this, the next group that we have is again standard numbers, that is 1 by 5, which is 20%. Then we have 1 by 10, which is 10%, which is half of 1 by 5 also we can say. Then we have 1 by 15. Now this 1 by 15 is not half of 1 by 10, but we can say it is one third of 1 by 5, for example. And that also means we'll have to do percentage ko also one third. So 20% divided by 3, because one third is divided by 3. So 20 divided by 3, you get 6.66% as the number. So that's about the third group, folks. Now, in the similar fashion, if we keep continuing and keep moving on, the next set of numbers, that is 1 by 7, which is 14.28%. Then after that we have 1 by 14, which is half of 1 by 7. So percentage also becomes half of that. So 14.28 ka half if we do, we get 6.7.14%. Sorry. Similarly, if we do half of that further, which is 1 by 28, then that gives you 7.14 ka half, which is 3.57, and so on and so forth. So basically, point of view is that we can still keep on doing this again and again for the similar sorts of number. So that's the idea. Now the next group that we have, these two numbers are related. 1 by 9 and 1 by 11. Unfortunate event of 9/11 can act as a trigger for you to remember that. 1 by 9 is 11.11%, and 1 by 11 is 9.09%. And if you'll see both these numbers, they both interchange each other. So that is the reason why we have kept them together as one group. So it becomes easy for you to understand and remember, basically. Now, there are a couple of numbers, obviously, as an exception, that there is no specific logics to them. So, unfortunately, you'll have to by heart them only. One of those numbers is coming up right now, which is 1 by 13. So, 1 by 13 is 7.7%, for example. This is one such idea. Then, moving on to the next number, the next group has three numbers in that, which is 1 by 17, 1 by 18, and 1 by 22. Now, none of them are standard numbers. So, what we will have to do is we'll have to first try and remember them, and there is a specific way to do that. So, for example, we can start with 1 by 18 as the number. The reason being 1 by 18 ka percentage is 5.55 percentage. The reason I like to remember this number is very simple. If you do, if you remove the decimal of these numbers, you get triple five, 555, and that is slightly easier to remember as a number basically. Now after this, there are two numbers, 1 by 17 and 1 by 22. One of the numbers, the integer part of this answer retains itself, and one of the numbers, the decimal part retains. 1 by 17, the answer is 5.88%, where the integer part retains itself. And obviously 1 by 22, the decimal part will retain, that is 0.55. So 1 by 22 ka percentage becomes 4.55%, for example. So this is the way you can remember it basically. And that's with the next group. The other group, now the next two groups are very similar. So if you understand one, the second one becomes simple enough, because the logic is ditto the same logic. So starting with the first group, there are again three numbers each. In the first group, the three numbers that we have are 1 by 19, 1 by 20, and 1 by 21. Now what we need to do is we need to remember 1 by 20, and 1 by 20 is 5%, because that's a standard number. Then 1 by 19 and 1 by 21. So 1 by 19 and 1 by 21. The logic is very simple. You can remember it this way because I remember it that way. So it becomes simple to recollect and figure it out smartly. So 5 ka square is 25, and in 1 by 19 the denominator is less than 20. So whenever the denominator is less, of course the answer will be slightly more. So 1 by 19 the answer will be 0.25 more than 1 by 20's answer. So that means 1 by 19 becomes 5.25. And why only 0.25? Because you can simply remember 5 ka square 25, so 0.25 greater. And 1 by 21, the denominator is more than 20. So obviously when the denominator is higher, the value becomes lower. So 1 by 21 becomes 4.75 because we'll reduce 0.25. And again, why 0.25 only? Because 5 square 25 and so on and so forth. So this is the way you can also remember this entire group of three numbers. And if you understand this, the next group becomes ditto the same thought process and the same logic. So next group, 1 by 24, 1 by 25, 1 by 26, out of which we can still remember the middle one, 1 by 25, because it is the standard number which will be 4%. Then 1 by 24 and 1 by 26. So 1 by 24, same philosophy, denominator is less, so the answer will be higher. 1 by 26, the denominator is more, so the value will be lower. Now only part is how much more, how much less. So again here 4 ka square becomes 16. So the above value 1 by 24 becomes 0.16 more than this, that becomes 4.16, and the other one becomes 0.16 less than that, so it becomes 3.84. Now 0.16, 0.15 doesn't matter, that kind of a small difference in these kinds of exams. Great calculation exams to the last very digit, but it is more of a common sense, and a logic also plays along with that. So 4 square 16, so 0.16 more, 0.16 less. That's the idea. Then moving on, the next group that we have is two numbers, 1 by 23, 1 by 29. I personally like to remember 1 by 29. The reason is very simple. 1 by 29, if you look at the answer, it is 3.45. Why only this number? Because if I remove the decimal, it becomes 345, which is three consecutive numbers, and that's the whole idea behind it. But 1 by 23, now 1 by 29 and 1 by 23, the only difference that you have to understand is for 1 by 23's answer, you'll have to simply interchange the position of 3 and 4. So that means 1 by 23 becomes 4.35%. And that is the reason why these two numbers were kept together as one group, so that it becomes easy for you to remember. The next group now, 1 by 27, single number again, the only single number, the second single number. So you'll have to remember that value. It is 3.7%. 1 by 27, 3.7%. So these are all the main groups, that is unique groups I would suggest, or I would call them. Now the next few groups are related to one of the past numbers that we have covered, and then there is obviously some more logic to that also, how to remember them more effectively. So let's start with the next group, that is 1 by 8 for that matter. So 1 by 8, we have already seen that it is 12.5%. Then we have 3 by 8. Now 3 by 8, we can simply say If I want to find out 3 by 8, what I'll have to do ideally is that 1 by 8 into 3. And I already know the value of 1 by 8, which is 12.5. So if I want to find out 3 by 8, I should be doing 12.5 into 3, which gives me the answer as 37.5% for that matter. And in the similar fashion, this means we can find out any fraction ka percentage which has a denominator of 8, because all we have to do is keep multiplying it with the numerator. Keep multiplying 12.5 with the numerator. So for example, the next number is 5 by 8. 5 by 8 ideally will come when you do 1 by 8 into 5. 1 by 8 is something which is we know already, which is 12.5. So 12.5 into 5, if we do, we get 62.5 percentage. Then we have 7 by 8. 7 by 8 will be obviously 1 by 8 into 7, which is 12.5 into 7, which gives us 87.5 as the answer basically. So this is how we can find out this particular group of 1 by 8, for example. Moving on to the next one, 1 by 9. 1 by 9 we already knew, 11.11%. Then the next one is 2 by 9, which is similar to what we have done earlier. 1 by 9 into 2, that is 11.11 into 2, which is 22.22%. Then we have 3 by 9, 4 by 9. We can have lot many such numbers. Just few examples we are picking here, which is 5 by 9, for example. So 5 by 9 becomes 55.55% because 11.11 into 5, for example. And then we have 8 by 9, which is 11.11 into 8, which is 88.88%, for example. So this is the way in which you can calculate all these numbers, for example. Similarly, we can have the group for 1 by 11 also. So 1 by 11 is 9.09%. You should be aware of that again, 911. Then we have 3 by 11, which is 1 by 11 into 3, which is 9.09 into 3, which is 27.27%. Then we have 6 by 11, which is 9.09 into 6, and 9 6 is 54, so 54.54%. Then you have 7 by 11, which is 1 by 11 into 7, which is 9.09 into 7, which is 63.63 percentage for that matter. So this is how we can find out these numbers basically. Again, which is connected to the previous numbers that we have figured out. I hope you are getting this idea of logic. Now, moving on to the next one, which is 1 by 7. So 1 by 7 we should be aware that is 14.28% as a number. Then there are multiple values, that is 2 by 7, 3 by 7, 4 by 7. As we have seen in the previous scenario, you can always multiply and keep getting those answers. But here what we will do is we'll try to learn a slightly different way. But to remember that, what you'll have to do is you'll have to remember six numbers, six digits in clockwise order, and those digits are 142857. And you should be aware of the fact that 1 by 7 is 14.28%. Now, how do we solve this? So, to solve this 2 by 7, for example, we should have a simple common sense that 2 by 7 means we'll have to do 1 by 7 into 2, which is 14.28 into 2. and then 14 2 is 28. So that means whatever is the answer of 2 by 7 will probably start from 2 for that matter. So that means 2 by 7, if we want to do, it becomes 2857. So we have to take 4 digits starting from 2 in the clockwise order basically. So 2 by 7 will start from 2, and then we have to take 4 digits in the clockwise order. So this is the way to do that. Similarly, we can figure it out for 3 by 7. So 3 by 7 will be 1 by 7 into 3, which is 14.28 into 3. 14 3 is 42. So 3 by 7, the answer will start from 4. And that means we'll have to do, starting from 4, we have to take 4 digits in the clockwise order, which is 4285, which means 42.85%. And so on and so forth. We can keep doing this for the remaining numbers also. Next one is 4 by 7. 4 by 7 is 14 fours are 56. So it will start from 5. So it will become 56 point or 57.14, because starting from 5, we have to take 4 numbers in the clockwise order. Then we have 6 by 7 and 5 by 7 also. So let's do 5 by 7 first. So that is 1 by 7 into 5. 14 5s are 70. So we have to start from 7, take 4 digits in the clockwise order, which is 7142, which is 71.42. And lastly, we can do it for 6 by 7 also. So 14 6 is 84. So that becomes, starting from 8, we have to take 4 digits, which is 85.71 basically. So this is the way in which you can remember all these fractions, and this is how the idea becomes easy for us to use them going forward whenever we talk about fractions. Now, since we are done with this idea of fractions, let's actually start with the concept of percentages. These are again all general concepts which will be applicable throughout whenever percentage is applied. So, for example, the first part of the concept is starting with a very, very important rule, and that rule is very simple, which is x percent of y is dash y percent of x. Now, how do I look at it is that the simplest way to tackle this is we can take some numbers. So let's for example take x as 10, and let's take y as 100. So this side becomes 10% of 100, this side becomes 100% of 10. When you solve that, 10% of 100 is 10, 100% of 10 is also 10, so that means they both are equal. So x percent of y is equal to y percent of x. You'll have to remember that. Now, what is the huge importance behind this? So the idea is very simple but extremely critical, in the sense that this simply means that if your numbers are same, both these numbers x and y, if the values remain the same, we can simply interchange, or we can simply shift the percentage sign from one number to other number without affecting the final answer of our expression. Again, what do I mean by that? So let's say, and this is again randomly I'm considering, so please don't judge me for that. As an example, So let's say we want to find out 32% of 6.25. Now the point here is, what you should realize is that whether is there any fraction that is available for 32 percentage. So I'm afraid not. You can obviously reduce and get it, but the standard number or the values that we have seen of fractions, it is not available. But point is that if we suppose change this percentage ka sign from 32 to 6.25, probably we can use the fraction. So for example, first what we will do is we'll change the question applying this rule, and then now the question first of all becomes this: y percent of x, which is 6.25% of 32 for that matter. And now we know the fraction of this number, which I think is 1 by 16. Yes, 12.5 ka half, which is 1 by 8 ka half, which is 1 by 16. And 16 twos are 32. Answer becomes 2 in a super easy and faster way. So the point here is, why these all things are important, because they make your life much simpler and less complicated, and that is the biggest reason why you should remember such things, and most importantly apply them also whenever it comes to your calculation. So folks, do remember this: x percent of y is equal to y percent of x, to make things easy. So that's the first rule. Now after this, what we need to remember is that, let's have a look at few statements first of all. So these are the statements. One of them says a is 25% taller. The other one says x scored 30%, y scored 20%, sales of the company decreased by 15%, and so on and so forth. So idea here is, if you go through these statements one more time quickly, you would realize something problematic, in the sense that all these statements are missing a very important part, and that part is something that is called as the base of the percentage. Now what is base of the percentage? So in very simpler words, with whatever number the comparison happens, or with whichever value the comparison happens, that value is called as the base of the percentage. So for example, if we get back that missing part in all the statements, you'll realize what I'm saying. So for example, the statement now becomes correct, all these statements, that is, first one becomes a is 25% taller than b, for example. So b becomes the base value. Then it says x scored 30% out of 50. So obviously 50 becomes the base value, and so on so forth. What you also need to remember is that with whichever value the comparison happens, that value is always called as the base of the percentage, basically. Now what we will do is we'll pick one or two statements from this, and then we'll try to analyze that with three four different methods, and we'll also probably recommend the one that you should be using for your calculation purpose. So let's start with the first one only. That is the simplest of all, that is a is 25% taller than b. Just now we saw, with whichever value the comparison happens, it is called as the base of the percentage. So that means b becomes the base value, because b के साथ comparison हो रहा है. And then the first method that we are about to see to explore this is something that you have been doing since school days, which is called as method of base 100. And as the name only suggests, in method of base 100, what we should be doing is that we should be taking the base value as 100. And we already know from the statement that b is the base, so we'll be taking b as 100. If we take b as 100, obviously a is 25% taller than that. So 100 ka 25% becomes 25 only. Taller hai, so we should be adding it into the numbers. So that means a ka value becomes 125, it becomes. And that is how the calculation works out. Simply remember, whatever is the base value, assume that as 100. taller tha, so we were adding that shorter we would have subtracted that number basically. And this is how you can figure it out. Then the next method, which is called as method of multiplying factor. Now, what is this method of multiplying factor? So point is that 25% we first need to convert it into a decimal. So 25% is 25 upon 100. If you reduce that, becomes 0.25. It becomes, and because we are doing percentage increase, because how do we understand that? From the word taller, so you have to add this 0.25 and hence it becomes 1.25. So point is that whatever is your base value, in this case it is b, we should be multiplying that with 1.25 to get the answer of a basically. And why plus? Because it was taller. If it would have been shorter, 25% shorter, we would have done 1 minus 0.25, because shorter है तो we should be subtracting the decimal, and 1 minus 0.25 becomes 7, 0.75 it becomes, and so on and so forth. Ideally, this method is something that you should avoid as much as possible. The reason being the simplest of all reasons that you are probably seeing also and understanding if you are looking in that direction, which is it always going to convert your answer into decimal, and you will have to multiply always with the decimal number irrespective of the numbers, whether your percentage is better or bad number. And multiplying by decimal has its own challenges, of course, so be careful while dealing with such things, because calculation can go wrong in such instances. Now let's do a small change here. So for example, let's change the statement. So now the statement is a is 5.88% taller than b, example. If we do it with base 100, then b is the base and b we will take it as 100, and then a becomes 105.88 if we do it with base 100. Taller hai, so we are again adding it in the base value. Shorter hota, तो we would have subtracted from the base value. Think of multiplying factor here, and it becomes even the worst of the methods to deal with the calculation. And this probably is the question where you understand that we need to think of a different approach to tackle these problems that we have faced right now as of now. And that is what we are going to explore in method number 3 and method number 4, for example. So method number 3, the name is method of fractions. Now what happens here is, first things first, you'll have to remember 5.88 ka fraction, which is 1 by 17. And also by reading the question, you'll have to identify something, whether there is a percentage increase happening or percentage decrease happening. So obviously, taller is the word that is being used here. So percentage increase only is happening. And for percentage increase, you'll have to remember one formula also, which is 1 plus base fraction. For percentage increase, the formula is 1 plus base fraction. And this base fraction is what? Basically 1 by 17. So this entire thing becomes 1 plus 1 by 17, which becomes 18 by 17. So what does this simply means is that whatever is your base value, which is b in this case, you have to multiply this b by 18 by 17, so as to get your final answer in the calculation. And because it was percentage increase, so the formula was 1 plus base fraction. Probably if you are guessing it or thinking it, for percentage decrease, the formula will be 1 minus base fraction, and so on and so forth. So that is method number 3 for you. So it solves all your problems in the sense that even if your percentage becomes bad number, you can always go back to fractions. But in the other methods, it becomes slightly challenging to deal with such kind of numbers. These methods are normally recommended. Okay, so this was method 3. Let's go to the method 4. Method 4 is even more better than this, and ideally my most favorite method, which is method of parts. Extension of fractions, but still few things are slightly different. So method of parts says whatever is the base value should always be the denominator value of the fraction. So for example, in this case, 17 is in the denominator, so 17 becomes the base value. And for the statement, B is the base value. So we can simply say B is 17 parts in our system, and then A is 1 by 17 taller than B. It simply means whatever is the value of B, A is one more or one extra than B basically. So B is 17, then A becomes one extra than that. So A becomes 18, 18 parts basically. So this method, why this is nice and most easy, because irrespective of your number, whether it is a good percentage value or a bad percentage value, if you know the fraction of that, you will not have to find out any decimal number, any fractional number. You will have to only do it with proper integer numbers every single time, and that's the benefit behind this particular method. Now, moving on, let's do one more such type of thing so that probably you become more confident of that uh, representation. And what we will do is also smartly, we'll not do it with all the methods, we'll only do it with method 3 and method 4 so that you can easily remember this. So this is the new statement now that we have, which says n as 3.45% less money than m. First, we'll do it with method of fraction, that is method 3. And for that, we should know 3.45 ka fraction. 3.45 ka fraction is 1 by 29. And we also have to identify whether there is a percentage increase happening or percentage decrease happening. So if you read the statement, it says less money. Less money is, of course, and for percentage decrease, as we discussed a bit earlier, the formula is 1 minus base fraction. For percentage decrease, the formula is 1 minus base fraction. Base fraction is something that we know, which is 1 by 29, which is 3.45 ka fraction. So this becomes 1 minus 1 by 29, and 1 minus 1 by 29 obviously becomes 28 by 29. So what does this means? That the m is the base value and it should be the denominator value of the fraction, which is 29 parts. So whatever m has, n has one part less than that. So m is 29 and n is one less than that. So n should be 28 parts, for example. So fraction ke point of view se if you think whatever is your base value, you have to multiply that with the base value. So 28 by 29 को m से multiply करना चाहिए, which was the base value, and then you get your final answer. Then let's talk about method of parts, which I have already just now spoken a bit earlier. So m is the base value and 29 is the base value because they both are in the denominator and they both are bases, so we can simply equate them. So m is 29 and n is 1 less than that. So if m is 29, n is 1 less than that, so n becomes 28 for that matter. So why I like this method is the same reason again. You don't get any fraction, you don't get any decimal, you keep getting normal, plain, simple integer numbers, which makes your calculation easier and simpler, and so on and so forth. And I hope you guys are understanding this part as well. Similarly, we have to see couple of more concepts before we go to the questions part. So the next concept is concept of percentage change. Now in this concept, what we are supposed to do is, there are two statements that are given to us and we have to find one of those answers that is mentioned. And the statement says, the first statement says A is 25% taller than B, and by what percentage is B shorter than A, for example. So the thing here is, first part of the statement, we'll have to analyze that with method of parts that we have just now done. So 25%, the fraction becomes 1 by 4, and then B is the base value and 4 is in the denominator, so we can say that B is 4 parts, and then A is taller than B by 1 part, and if B is 4, obviously A becomes 1 more than that, which is 5 parts. Now in the second part they are asking the percentage, and for percentage, by now you should understand, you need to have a fraction. Once you have a fraction, you can do percentage, and vice versa, of course. And we know now in the second half the comparison is happening with A, for example, because it is mentioned by what percentage is B shorter than A. So the base value is A, and A we have already figured out, which is 5 parts from the first half of the statement. So in the denominator we'll have 5 as the number, and then they are saying B is shorter from A by how much? So we know the answers of B and A from the first go. B is 4, A is 5. So clearly we can say B, which is 4, which is one value less than 5, which is A. So the fraction becomes 1 by 5, and 1 by 5 becomes 20%. So when we say same statement, A is 25% taller than B, is as good as saying B is 20% shorter than A. Not 25%, 20% shorter. One more logical way to understand this is that you can see that the reference has been changed. The earlier reference or the comparison was happening with B. So you have to find out the value with respect to B because it is compared with B. Here in the second half, they are saying B is smaller than A by how much? So now the comparison is not happening with B, it is happening with A. So we have to take A's value as the base value, and that is the reason why we have taken 5 as in the denominator. I hope you are getting this aspect. There is one more. So I would suggest pause this video as of now, right now. Try this yourself and see whether can you get the right answer or not. So the statement says X scored 4.75% less than Y. Then by what percentage has Y scored more than X, for example? So here again the same thing will be applied. So first things first, 4.75 ka fraction, which is 1 by 21, and the comparison is happening with respect to Y. So Y is the base value, and we know already 21 is in the denominator, so we can say Y is 21 parts, for example. And then they are saying X is doing one less than that. So if Y is doing 21, of course X is doing one less. So X is doing 20 parts only, is what we can say. And then they are asking by what percentage has Y scored more than X, for example. So again, the comparison in the second half is happening with respect to x. So in the second half of the fraction, in the denominator, we should have x's value, which is 20 parts. And what they are asking is y has scored how much more than x. We know the numbers. We know that y has done 21. We know that x has done 20. So they are asking y, which is 21, has done how much extra, how much more than x, which is 20. So clearly it is one part more than 20 than x. So that means the fraction becomes 1 by 20, and 1 by 20, the percentage becomes 5%. So when we say x scored 4.75% less than B, it also means B has scored 5% more than A, or Y has scored 5% more than X, for example. So that's about percentage change as a concept. There is one more last one, that is something called as offset change. Now first of all, we need to understand what exactly is meant by offset change. So offset change is an idea which is utilized when you want to bring your value back to the original number. For example, let's look at the definition first. So the definition is percentage by which a changed value should be either increased or decreased to bring it back to the original value. And this part is the key part, bring it back to the original value. Now what we will do is we'll see a couple of examples so that you also understand that what needs to be done here in such type of expressions slash questions, for example. So the first statement is a 20% increase can be offsetted by dash. So again, what we will need to do first of all is we'll have to find out 20% ka fraction, and 20% ka fraction is 1 by 5, for example. So we can say that the base value is 5, and on that base value we are increasing by 1. So obviously we'll arrive at 6, for example. We are at 5 right now, which is the base value, and from there we'll increase by 1 and we'll arrive at 6. So now we are at 6, but what is offset? Now we are at 6, but we want to come back to previous number, that is 5, for example. Obviously from 6 to 5 we'll have to reduce by 1, but mind you, whatever is this reduction of 1 is happening on a base of 6, for example, and hence the fraction becomes 1 by 6, and 1 by 6 is 16.66 or 67 percentage for that matter, and hence they have said the answer as the same number, that is 16.67% decrease that is happening. So if there is a 20% increase, then it can be offsetted by a 16.61% decrease, and so on and so forth. Moving on, there is one more which says a 6.66% decrease can be offset by dash. Again, 6.66% is 1 by 15. So 15 is the base value and it's a decrease. So on a base of 15, a decrease of 1 is happening. That means we'll arrive at 14. But from 14, we want to go back to the original number. So you'll have to increase the value by 1. But then mind you, this increase is happening on a base of 14. So your fraction becomes 1 by 14, and 1 by 14 is 7.14 percentage. All of this is called as offset change to bring it back to the original value. That's the key element which will be mentioned in the questions, of course. So these are the concepts that are associated with percentages, and as you would have realized, these are very very general concepts, so it will be applicable anywhere else also in the same manner whenever percentages are in the picture. So now let's do few questions so that you also understand how does this entire thing work out to be, and you will be able to see whether you can do the same for yourself or not whenever you are solving these sorts of questions. So for every question, I would suggest the same thing. Pause this video right now, try this on your own, and then try and see the solution, because that's only when you'll realize where you went wrong, what mistakes you made, etc. etc. So the first question says 74% of 625, yeah, 6.25 rather, is equal to dash percentage of 111. Then obviously, what is the value of question mark? We have to figure that out. So to solve this, obviously first on the left side, what we'll have to do is we'll have to apply the rule x percent of y is y percent of x. And when we do that, what will happen is the sign of percentage will shift from 74 to 6.25. And why did we do that? Because then we can use the fraction of 6.25. So 6.25 ka fraction is 1 by 16. So this is what the solving part becomes. And henceforth we have to find out the value of question mark. So obviously this 111 comes on this side. So it will divide, because here earlier it was in the multiplication. Off is normally multiplication. Bodmas rules you will understand later on. And then this 111 is here. Now we simply have to reduce these numbers. So if I divide these by 2, it becomes 8, and this becomes 37. 37 2s are 74. And then why numbers are supposed to be good, because all these things you will only and only realize then. 37 3s are is 111. So this simply means 1 by 8 into 1 by 20, 1 by 3, which again means 1 by 24. And 1 by 24, the percentage, if we ask, I think it should be 4.16 percentage, which is answer option 3 as the answer. And this is the way to solve that question. So x percent of y is equal to y percent of x, and then we did the solving part, and then the fractions and the percentage wala idea, which is this. Here is the second question. It says the number of candidates taking CAT this year was 65334, and there was a 14.28% decrease over the previous year. Then how many students took CAT last year is what they are asking. See now, how do we go about this? So first you need to understand that there is a 14.28% decrease over the previous year. So previous year is the base value, because comparison is happening with that. First things first, 14.28% ka fraction is 1 by 7, and there is a decrease. So we can say that the previous value was 7, which is the base value, and we are decreasing it by 1. So we'll arrive at 6 because it decreased by 1, for example. Now these are all R numbers. In their system, they are saying that the number of candidate taking CAT this year was 65334, and this 65334 was a decrease of 14.28% that has happened in the base of last year. Obviously, last year's number should be higher and current year's number should be smaller. So out of 6 and 7, 6 becomes the current year's number. So ours is 6, theirs is 65334, and then they're asking how many students took CAT last year, which is obviously 7. We do not know that. Suppose that is x. All we have to do is simply cross multiply and you will get your answer. So 6 into x is equal to 7 into 65334. If I find out x, it becomes 7 into 65334 divided by 6. And you will have your answer after all the calculation. I think it is 76223, which is answer option 5. So this is how you can do the calculation. Method of parts is something that is very, very important. Question number 3. In a town, only 25% of the population eat rice. Of the remaining one third are eating wheat only. Of the remaining 20% are eating jawar only. And the remaining 112 people are eating bajra only. Find the total number of people in the town is what they are saying. So how do we do this? Couple of ways. You can start with any option as the number and check for all these calculations. Whatever number matches with 112 as a last answer, you are good to go with that answer as the correct answer. If not, because few questions are theta in CAT, so if you do not have options, you will not know what to work with. So in that case, what we'll have to do is we can start again with a similar kind of thought process, if not the same. Let's assume total number of people in the town as something. For example, let's take it as 100. Then they are saying only 25% are eating rice. So 100 ka 25%, which is 25 only. This 25 are eating rice is what they are saying. And now comes the important part and why you should read it carefully and apply it also, which says of the remaining one third are eating wheat only. First, you'll have to figure out if out of 100, 25 are eating rice, how many are left out? So obviously 75 are left out. And out of those 75 remaining, one third are eating wheat. So 75 ka one third becomes 25 basically. Then again they are saying of the remaining 20% are eating jawar only. Out of 75, 25 are eating wheat. So remaining are 50. And out of 50, 20% are eating jawar. So 50 ka 20% is 10 people. 10 people are eating jawar, for example. And then they are saying, and the remaining 112 people are eating bajra only. So in our case, out of 50, if 10 are eating jawar, we are left with 40 people who are supposed to eat bajra. But ours is 40 and theirs is 112 is what they are saying. And again, they have said the same thing. Total number of people in the town. We have assumed total as 100. Theirs we do not know. Suppose question mark or x. Cross multiply. You will get your answer in one step only. And that's the best part. So we can do 40 into x is equal to 100 into 112. So to find out x, 40 goes on that side. When you do that, you get the answer as 280. So there are 280 people in the town as a total, which is option 1 for question number 3. Now the idea here is it is not necessary that you assume 100 only. You could have assumed 200, 500, 700. Doesn't really matter as long as the numbers satisfy. If at all you face any issues that the numbers are not coming in that manner, maybe let's say decimal number is coming or something like that, then you can always go back and change the assumption. It's not much difficult task to proceed or function in this particular manner. So that's your question number three. Yes, they are also doing the same thing. Let's talk about question number four. In an election, voters cast their votes either for X or for Y only, and Y wins by 20 votes. Had X polled 5% more votes than what he did originally, then there would have been a tie in all how many votes are cast. Now, again, what you can do is assume some values for both X and Y, and they are saying that Y wins by 20 votes. So, this simply means that whatever number of votes X is getting, Y is getting 20 more than that, for example. So let's assume X is getting A number of votes. So Y will get A plus 20 because he is winning by 20 votes. Then they are saying there should be a tie. Now think about this. If there is supposed to be a tie happening, so as of now, there should be a transfer of 10 votes from X to Y. Because if there are 10 votes transferred from Y to X, sorry, then X will have A plus 10 and 20 votes are out from Y. So obviously Y will have also A plus 10 and they both will get the same vote, which is the condition of tie. So from here we understand that for a tie to happen, there should be a shifting of total 10 votes that should happen from Y to X. But they are saying in the condition, had X polled 5% more votes than what he did originally, then there would have been a tie. So originally X got A number of votes is what we have said. If it would have gotten 5% more on or more on that, there would have been a tie. So for equation perspective, what we can say that 5% more and 5% of A because X got A number of votes originally, and this number is equivalent of tying of votes, which is 10 votes ka transfer. You solve this, 5% is obviously 5 by 100, goes on the other side, and you get not 100, sorry, 10. My bad. Yeah. 10 is equal to 10, not 100. So 5% is 5 by 100 into A is equal to 10. And then you solve this, this gives you 200, I think, as the number. So what does that means is that A originally got 200 votes and X got 220 votes. If the 10 votes would have shifted from Y to X, there would have been a tie, which is surely. But the question is not how many votes individually or any one of them has got. The question is, in all, how many votes are cast? That is the total votes they are asking. So obviously, total votes is something that means we'll have to add them up, which is going to be, I think, 420, which is answer option 3, according to my thought process, my calculations. So this is how you can again do it. So read slowly, read one statement at a time, and then try and figure out solve such kind of questions basically. Let's do the fifth one. The price of the tomatoes reduced by 12.5%, because of which a housewife is able to buy 5 kilos tomatoes more for rupees 140. Find the original price per kg of the tomatoes, is what they are saying now. So here a lot of people make mistake if you are not careful while reading this. Is they think that they are getting 140 rupees by 5 kilos of tomatoes, which is not the case. She's getting 5 kilos more than what she got earlier in the same 140 rupees, because the price has gone down by 12.5%, for example. So we'll also have to incorporate that. So 12.5%, let's use the fraction which is 1 by 8. So we can say simply the older price was 8 and the new price is decreased by 1. So if 8 is decreased by 1, it becomes 7, for example. And then because of this process, the benefit that the housewife got is that she got 5 kilos of extra tomatoes. So we can simply say the price has gone down by one part, 8 has become 7, and because of which the housewife is able to buy 5 kilos more tomatoes. So one part is 5 kilo, 7 part is 35 kilo, and 8 part is 40 kilos basically. And we seriously get the answer just like that, because we can simply say earlier she was buying 35 kilos because the price was slightly higher, price was slightly more. And now, because the price has gone down by 12.5%, he is going to get the benefit of that because the price has reduced, so the quantity will increase. So now she is getting 8 parts worth of tomatoes, which is 40 kilos, because 8 fives are 40. One part is 5, remember. So 5, 7 part is 35, 8 parts is 40, 8 fives are 40. And the story matches because they also said she is getting 5 kilos more than what she got earlier. So, yes, now she is getting 40 kilos. But again, the question is not how many kilos she is getting or something, it is original price per kilo of the tomatoes. So originally, obviously, she was getting 35 kilos, and she was getting those 35 kilos at 140 rupees. So original price per kilo becomes 4 rupees. 140 divided by 35. If they would have asked us new price per kilo, they would have divided by 40. So 140 divided by 40 would have been 3.5%, 3.5 rupees per kilo as the price, for example. So that's the answer for question number 5. Let's talk about question number 6. One of the simplest questions, but again, you still have to understand and nail it in a faster way. So it says 10% of income of P is equal to 20% of income of Q and 15% of income of R. If the income of R is 15,000, then the income of P is dash. So let's first formulate it. 20% of P is, sorry, 10% of P is 20% of Q, and 15% of Q is 45% of R. If your numbers are good, and they should be, because then the benefit is immense in such type of questions, and see how fast and how easy you can make it. So we can say 10 twos are 20, and 15 threes are 45, for example. So from here we can simply say that Q is 3 times of R, and from here we can say that P is 2 times of Q. What we can do is we can substitute the value of Q as 3R in the process. This becomes 6R then P and R के बीच का relation. They have given us the R का value which is 15,000 and they are asking P का value. So P becomes 6 times of R which is 15,000 into 6 which is 90,000 and straight away you can have this answer in a much easier and faster way which is answer option 5 for that matter. So this is how you can do question number 6 for example. Question number 7. The price of the table increases by 10% and that of the chair increases by 15%. How much more does one have to pay for 5 chairs and 5 tables? Now, here, first thing you should realize that is it can be for 5 chairs, 5 tables, or 10 chairs, 10 tables, or 1 chair, 1 table, 100 chairs. It doesn't really matter because the multiplying factor will remain the same in both the scenarios. So, whichever number you do it for, the percentage value will not change. So, don't worry too much about that calculation. But yes, normally what we do is whenever percentages come, we assume 100 and we try and work it out. So let's try and see that. So for example, it says the price of the table increases by 10%. So suppose if you assume the price to be 100, it increases by 10%, so it becomes 110. And then the price of table chair increases by 15%, so it becomes 115. Let's do it, let's say for 50 pairs, and as I said, it doesn't really matter which numbers you do it for. These are the prices, old and the new. And if you take the percentage increase from the new price to the old price, you will find out that it is increasing by 12.5%, which is present in the option as the first answer, but do not mark anything as the answer. The reason to that is very simple. The whole challenge in this entire process was, and you have to identify and figure that out carefully. That is, do we know for sure that the price of table and chair is 100 only to begin with? So, unfortunately, not, because nothing of that sorts is mentioned. They have not said the price of the table and chair is same or equal or whatever, or not given also. If it would have, they would have given us, we would have done that calculation. Now, let's see what happens when we change that assumption. So, suppose now the table costs $1,000 and the chair costs 10 rupees and table is increasing by 10%, so it becomes 1000 ka 10% is 100, which becomes 100 and 1100. Chair is 10, increases by 15%, which is 1.5, so it becomes 11.5. Let's do the calculation again. Let's say for 50 pairs, these are the numbers. Now, when you find out the percentage change in the price or the percentage increase in the price, you'll realize that it is increasing by 10% only, approximately, of course. And now the problem is that I do not know if I change this number even further, will I get the same answer or will I get anything different apart from this idea? And that is exactly what you need to understand here when you are dealing with such type of questions. So the whole point is the answer should be cannot be determined, and the reason is very simple. The initial price of table and chair need not to be same, and neither they have mentioned it to be same. So first, while reading the question, you should be able to figure it out going forward. If they have given same, then assume 100, answer becomes 12.5. If they have not given anything, don't even solve. Cannot be determined is your answer, and so on and so forth. I hope you are getting the hang of such type of questions. Let's do question number 8, which says in an election for the post of the CM, 60% voters favored L. So again, we can do that kind of calculation, assuming total votes as 100, 60% and 60 people favored L, rest favored R, so 40 people favored R. But after a few days, 35% of L supporters shifted their support to R. So we'll have to calculate 35% of 60, which is 21. So 21 people of L went with R, and 10% of R supporters shifted their support to L. For example, R had 40 voters, 10% of that will be 4. So R's 4 people are coming to L for, for that matter. So let's first do the totals now. So these guys, the total becomes 43, and for these guys, the total becomes 57 for R. And then they are saying what is the minimum percentage of total voters L now must attract in order to tie with R. Again, L wants to tie with R. That means that both votes should be same. So how many votes first of all should shift from R to L? So clearly 7 votes. Why? Because if 7 goes from here, comes here, they become plus 7. And then 7 goes out from here, they become minus 7. So they will also have 50 and there will be a tie, for example. So 7 votes should be shifting. But the problem again is that they are not asking how many votes, they are asking percentage of total voters. So 7 votes are shifting and total voters are 100. So 100 out of 7, obviously 7% only, for example. So from the options, none of these should be the answer, which is 7%. Now let's say if you would have taken some other number just out of curiosity. Suppose 200 if you would have taken, everything become everything becomes double of the previous numbers. So in the last instance also, instead of shifting 7 numbers, it would be shifting 14 numbers. But again they are asking percentage. 14 votes out of total 200 votes, which again means the same after reduction. So mind you, that is why percentages are dangerous or scary or tricky, because the number may remain same in terms of percentage, but the original values, the absolute values can keep on changing drastically. And if you can understand that and use it to your advantage, you can play with numbers. If not, then it becomes difficult. So that's the whole learning as well, along with the ideas that we are exploring in terms of application. Okay, now the next one, that is question number 9, which says on Monday, Darshan withdraws 34% of his bank balance and on Friday deposits 56 rupees, and as a result of which his bank balance is now down by 20% as compared to Monday's opening balance. What was Darshan's Monday's opening balance on Monday, assuming no other transaction during the period? Okay, so Monday he withdraws 34%, Friday deposits 56 rupees, in between no transaction, but the bank balance is still down by 20% as compared to Monday's opening balance. Now, here, what you need to understand is earlier it was down by 34%, now it is still down by 20%. So that means the 56 rupees that he has deposited on Friday in the account, that has taken care of 14% of his deficits in terms of bank balance being down basically. So we should be comparing with the same number, that 14% of deficit got covered by 56 rupees, and they are saying what is the Monday's opening balance, original opening balance. So Monday's opening balance, let's assume it to be 100. 100 is how much? If you know tables, 14 forza 56, 100 forza 400 should be the answer in this particular case. Yes, 400 is the answer. So this is how you can solve such easy type of questions. You'll understand what they are saying. Simple, straightforward data, straightforward calculation. Should not have issues with these types of questions. Let's do the 10th one, which says Pragati has enough money either to buy 40 chocolates or 50 candies. The key part is or, not both, or either of which. She decides to spend only 82% of the overall amount, and she buys 26 candies. How many more chocolates can she buy? Is what they are asking. Now, the way to solve this question is you can assume a number, you can assume a value of amount that she has, which makes it easier for you to understand this uh, greatly. And one more suggestion to keep the numbers intact, what we can do is ideally while assuming the number, it should be a number which is common to both these numbers, which is 40 and 50 for that matter. So, common multiple of 40 and 50 is 200. So let's assume she has 200 rupees as an amount with her. And in those 200 rupees, she is buying 40 chocolates or 50 candies, for example. So in 200 rupees, she buys 40 chocolates. So that means the chocolate ka price becomes 5 rupees per chocolate. And in 200 rupees, she is buying 50 candies. So candy ka price become 4 rupees per candy. Now, she's not spending the entire amount. She's only spending 82% of that. So 200 ka 82% obviously is 164 rupees. So she's going to spend only 164 rupees. And then she buys 26 candies. For one candy, we know the price, 4 rupees per candy. So for 26 candies, she will be spending 104 rupees from 164 rupees. So she'll be now left with only 60 rupees. And in those 60 rupees, they are asking how many more chocolates she can buy. So per chocolate ka price is 5 rupees and she has 60 rupees left. So in 60 rupees, 5 rupees per chocolate, she can buy, I think, 12 chocolates, which is answer option 1 in this particular question. Question number 10 for that matter. So this is how you can solve this last question as well. So folks, we are done today for percentages.